Hi, thanks for watching this session. I'm going to talk about right-sizing file servers. I'm going to go through some metrics and some tools that we use to capture and do some performance testing and look at the results of those, and then talk about some recommendations on sizing file servers. So I'll just talk with a bit of background around this session. So my name is Aaron Parker. I'm a solutions architect at Atlantis Computing, based in Melbourne in Australia. And I'm a Citrix technology professional, Microsoft MVP. And this session actually comes out of a couple of other sessions that I've been doing with a couple of other guys over the last few years around folder redirection. So what we've done with this slide, I've kind of distilled the file server component into this 15-minute talk. So I've been doing this session with Helge Klein. He's the creator of Uber Agent. So if you're doing, say, things like VDI, user experience monitoring, then Uber Agent's a pretty cool tool to use. And also Sean Bass, who's the CTO of the desktop technologies at VMware. So together, the three of us have been putting these sessions together around folder redirection over the past couple of years. And I'll just talk about the file server piece in this presentation. So we looked at a couple of different tools that we can use to do things like modeling file servers, modeling perhaps your virtual hardware and your physical hardware configuration, and seeing how you should size your file servers and what type of performance you get out of different configurations. Now, as far as home drives go, there's probably not a lot of tools around that can actually use for modeling, but one of the tools I did find that came from Microsoft is the file server capacity tool. So we've used this tool. I'll talk about what it is and how to use it, and then I'll show some results that you can get out of the file server capacity tool. So yeah, it's freely available. You can go download this and run it up in your environment and use to do some modeling. So essentially what it does is it models or simulates client workloads on SMB shares. So that could be an SMB share on a Windows box. It could be an SMB share on a NetApp piece of storage if you wanted to. Anything that can present SMB, then you can utilize with the file server capacity tool. And what it does is it returns standard Windows performance metrics from the file server and from the client, and with that to get at the end of it, it gives you kind of a score or a report on your configuration. So in these particular tests that we did, we've used the virtualized file servers. We configured those with 2 vCPUs and 4 gig of RAM, and we've tested both 2008 R2 and 2012 R2 on the back end, and concentrated on Windows 8.1 on the front end. So if we do a second round of testing on these, say next year, then we might look at Windows 10, for example. So the tool itself is pretty straightforward. It's just a set of executables that run. You run it on your file server, run it on your clients that simulate the load, and you have a controller that actually then controls the simulations across all of these nodes. So in these scenarios that I've used a single VM actually sitting on an SSD. I've used 4 VMs to simulate up to 800 user connections. So each of those clients runs up to 200 connections, or if you want to go beyond 800, whatever it is, you configure it to do what you need to do. So what you do is you run FSCT through a number of test runs. So you have a start and an end count. So you might start at 50 users and then scale up until you essentially break your file server. So in this instance, I've scaled or started at 50 users and scaled up to 800 users. So the way it works is you'll configure it, run a test. So start at 50 users, and then that test runs for about 10 minutes while it does its thing, and logs some metrics for you, and then goes ahead and does the second test. So scales up again by whatever number. So in this instance, I chose 50 users. So I've gone from 50, 100, 150, 200, 250, and so on. And each time it just goes and runs the test up to X number of iterations until you reach your final number. So if each of those runs takes about 10 minutes, you get a complete test which run in the range of 3 to 5 hours it was taking me. So it's not the sort of thing that you just sit there, last thing Friday afternoon, do it before you go home. You might actually kick this off overnight and then come back the next morning and look at the results. But certainly a very, very interesting tool. So I've got a couple of scenarios, just distilling some of these down into short sessions. So I'll run through CPU performance first, and this shows, I think, some interesting results. So what we've done is we've kept the same configuration but changed the file server operating system on the back end. So effectively what we're doing is looking at the impact of SMB 2.1 and SMB 3.01 depending on the client and server that you're using. So what this does is the results we get start at 50 users, end at 100, and we can look at the average CPU utilization on that file server. Now, we can also look at the maximum CPU utilization on that as well. So average is fairly standard, goes off in a nice even line, but maximum tells quite a different story. So there's quite a large difference between average CPU and maximums. So some of these maximums can tend to have an impact on user experience. And maybe if the maximum only hits 80, 100% CPU, for example, for a very short amount of time, then you're only going to impact the user experience for a short amount of time. But the key thing there is there's quite a big difference between average and maximum. So we need to be sizing for our maximums. Now, if we run exactly the same test, but this time look at SMB3. So what we've done is instead of Windows 2008 R2 on the back end, now we have 2012 R2 on the back end. Clients remained 8.1. Our maximum CPU utilization looks very similar. The average looks very similar. The line's pretty much the same, but maximums tell a very different story. So what's happening here compared to SMB2 or compared to Windows 2008 R2, your maximum processor utilization drops quite significantly. So there could be a saving on your infrastructure or your virtualized infrastructure in the back end just by upgrading to Windows 2012. Now, of course, you should take advantage of SMB3. Your front end also, your clients need to be able to talk SMB3 as well. So if you upgrade to 2012 on the back end, you need to upgrade to at least 8.1 or Windows 10 on the front end. So next one I've done is, okay, we've done these tests, we've run through, started at 50, ended at 800. We can get an idea of how that configuration performs. And as perhaps I keep scaling on above 800 users, do I need to add more RAM, or do I need to add more vCPUs, or do I need to scale out the number of file servers that I have so we can model that with the file server capacity toolkit. Now, those tests will run out antivirus. So now this one tells quite a bit different story. So now this is the same test as previous, still looking at SMB3, so 2012 R2 on the back end. Average and maximums there, exactly what we've shown before. But now let's add antivirus to the mix. Now, average CPU is now starting to hit, especially after about 600 users, is starting to hit what our maximums were previously. So now we look at the maximum amount of CPU with AV, and it's a massive jump. So antivirus has a massive impact on the CPU utilization on your file servers. So if you think about the way AV works, it needs to step in and look at every I/O transaction, and it's adding CPU overhead on top of that. So now I have to start sizing for the maximum amount of CPU utilization I'm using with AV. So this is a standard enterprise AV product, installed, not tweaked, all out of the box defaults, and it has quite a large CPU impact on your file servers. So big recommendation here, I think, is to compare different AV vendors and see what impact they have on CPU. So there's also another tool, there's a whole heap of other scenarios that you can go through with the file server capacity toolkit. Because it pulls back standard performance metrics out of Windows, you can look at network throughput, you can look at disk throughput and so on, so you could measure the impact with SSDs or the impact with spinning disk. But there's another tool that you can also utilize, and this is the disk speed tool from Microsoft. So this is a command line tool. I think it's there's a blog post, you can find it through Google, download it. Just a standard command line executable that you run, and you can do different types of throughput tests. So you can set the size of your I/O. You can do read and write tests and change the mix of, do I do heavy reads or heavy writes and so on. So what we went through in this particular one is looking at the difference in utilization between network throughput on SMB 2.1 and SMB 3. So what this graph is showing, really there's no great difference in throughput. The protocols act pretty much the same. We might expect to see pretty much the same thing when we go with Windows 10 as well. But what this does show, what I've done here with this test is I've run the hypervisor in high performance mode. So the default's going to be balanced, but in my lab I've set the hypervisor in high performance mode. So I reran the test and set the power profile back to balanced. And this has a very big impact on 4 and 8K blocks. So if we're talking about file servers and home directories especially, you're going to see a lot of 4 and 8K blocks on the transactions on these file servers. So what we might be doing in VDI environments is setting our compute or our hypervisor in high performance mode. This is something you should also be investigating in on your back end as well to deliver some extra performance. So there's a whole lot of other scenarios that we can go through, and this is only a fairly small snapshot of the types of things that we've done. So I'll just summarize, I guess, with a number of recommendations. So a file server capacity toolkit is about the best tool that I've seen. It's free from Microsoft. It does home directory simulations built into it. I think you can go and write your own if you need to, but this out of the box it'll do home directory simulations. Probably the downside of it is it hasn't been updated since about 2011, but as I say, it's about the best tool that we've found. But it is very useful for essentially simulating load on your file servers until you get to a breaking point. So you can work out not only the configuration I might need for my virtual machines, but perhaps the configuration I need for my physical compute, and how do I start to scale out with the number of file servers that I need. So utilize the file server capacity toolkit to model that. Definitely multiple vCPUs, especially with things like antivirus, and the toolkit can help you determine how many vCPUs you might need. Size for peaks, so if you are implementing antivirus, which pretty much we all are, then you need a size for the impacts of that antivirus. Hypervisor resource sharing is certainly something to look at as well. So watch the overcommit level that you have on your hypervisor layer. If you are consolidating file servers, maybe you need to look at how you've got the number of virtual machines versus the amount of CPU capacity you have available to on your compute layer. Set the hypervisor in high performance mode to help with the user experience, especially around those 4 and 8K blocks, and that will certainly improve the performance on those file servers. And that will help with things like logins or launching documents or an application that might be on that file server perhaps. Expect the performance of impact of antivirus. Maybe shop around, test various antivirus vendors and see which one has the least amount of impact in your environment. And investigate scale out options. And that's probably a whole nother session in and of itself. There's different third-party scale out solutions that you can utilize. You might utilize distributed file system from Microsoft, or you might use something else, whatever it is. You might look at how you scale out not only across multiple file servers, but how you scale out those file servers across compute, and how you implement that as a contiguous workspace. So yeah, I think that's about the end of it. Thanks for watching, and if you need any more info, you can reach me at stealthpuppy.com or stealthpuppy on Twitter. Thanks.